Another video on elimination, but this one with multiplication. Let's take a look. For many systems, neither one of the variables will have the same coefficient in both equations. We've been seeing a lot of, like 2x minus y equals 2, and then negative 2x plus 3y equals 6 or something like that. And it's pretty obvious what you should do with elimination. Either the same coefficient or the opposite coefficient, 2 and negative 2. If this is the case, we have to multiply either one or both of the equations by a number to make the coefficients the same. So let's look at an example like this. 2x minus y equals 8 and 5x plus 3y equals 9. So here we see the x coefficients 2 and 5, not a ton in common there. We got negative 1y and positive 3y, 8 and 9 at the end. Elimination doesn't look like it's going to be super easy. Fortunately, we can do something to every part, just like we would when we're manipulating equations and going from different forms. We can multiply all of the top, and I'm going to focus on the y here because it's negative 1y, so I can multiply it by 3 and have it line up with the positive 3y below. So I multiply everything in the parentheses by 3. 3 times 2x is 6x. 3 times negative y would be negative 3y. And then 3 times 8 is 24. Now, I don't have this anymore. I can use my elimination, and I'm going to add these because the 3 below here is negative. Positive 3 plus negative 3 would be 0. I can add these. 11x equals 9 plus 24 is 33. And I know that x would equal 3 here. I'm going to go through and give some further examples and procedures, but just a quick example of what we can do to manipulate and multiply so that the equations can have a coefficient that's the same. Solving elimination with multiplication procedure. Now, for those of you that have been paying attention, this looks very similar, except for step number 1. Step number 1, multiply one or both of the equations by a number to make one of the coefficients equal. We got to make sure we multiply everything. And then the rest of the steps from here down are going to be the same as elimination. So you don't have to rewrite everything. You just need to make sure that you can do step number 1. Let's go through some examples. Example 1. Solve the system using elimination. X plus 3y equals 6, and 2x plus 4y equals 10. Right away, I see the 3 and the 4 for the y. I'd have to multiply both, but x and 2x, I like that because I can multiply the top by 2 and go from there. So let's go into multiplying the top by 2. So I'm going to end up with x times 2 is 2x plus 6y equals 12. And then I'm going to keep my second one as is. 2x plus 4y equals 10. I need to subtract these. I have to choose add or subtract. If I add, that'd be 4. So 2 minus 2 cancels out. 6 minus positive 4 would be 2y. 12 minus positive 10 is 2. So y should equal 1 here. Now, I'm not quite done yet. I need to plug in y into one of my original equations. Let's take the top one, and we'll check with the second one. So I have x plus 3, and then instead of y, I'm going to do 1 equals 6. And I got that equation from the top here. 3 times 1 is 3 equals 6. X plus 3. I'm going to subtract 3 from both sides, and I should get x equals 3. So my ordered pair is 3, 1. I'm going to make a little space so we can check this. Using my second equation, the one we didn't use for solving for x, and we'll plug it in to make sure it still works. 2 times 3 plus 4 times 1, does that equal 10? Well, 6 plus 4 does equal 10. So this works. This is our answer, 3, 1, using elimination and multiplication. Example 2, solve the system using elimination. I've got 3x plus 5y equals 46, 7x minus 2y equals 39. Looking here, the 3 and the 7 x's, that doesn't look too great. I think 5 and negative 2y, there's some promise there, but I'm going to multiply both equations here by a number. So my plan is to multiply the top, I'll use top in red, by 2, and I'll multiply the bottom by 5, so that I can cancel out and eliminate the y values. Let's do the top first. 6x plus 10y equals 46 times 2 should be 92, I believe. And I'll multiply the bottom by 5. I've got 35x minus, and I've got 10y, that's going to work out really nicely, equals 195. 5 times 39, don't expect you to know that off the top of your head. Maybe you do. Now, should I add or subtract these? I'm going to add. That cancels the y's. I'm left with 41x equals 287. Divide both sides by 41, and x should equal 7. Wow, that worked out really nicely. Good sign for us. Let's plug in x equals 7 to the top one here. So instead of 3x plus 5y equals 46, we'll do 3 times 7 plus 5y equals 46. 3 times 7 is 21. Subtract 21 from both sides. 5y should equal 25, and y would equal 5. If those are my ordered pairs there, let's double check it. Should be 7, 5. Plug it back into my second equation. 7 times 7 is 49, minus 2y, which would be 5, which would be minus 10. 49 minus 10 is 39. Does 39 equal 39? You betcha. Awesome. Let's try it on our own. Solve the system using elimination, and make sure you have a great day.